part 1 of section 6.4, polar coordinates, and going along with that, section 6.5 will be polar graphs. So let's start by introducing what polar coordinates are. So we have another coordinate system. We have our rectangular, we have our parametric, and now we're going to talk about a polar coordinate system. It's an alternative to the Cartesian system, and it's a way to locate points in a plane. It consists of a fixed point called O, which is the pole or the origin that we know in the Cartesian system, and a ray, OA, that's fixed, which we would equate to the x-axis. And that is called the polar axis with O as its initial point. So we have a pole and a polar axis. We only really have one direction when we're talking about our axes. But both r and theta can both be positive or negative, because how we find points in a plane is we have a radius, so that's a point along a ray, and we have an angle that is made with the polar axis. So the directed distance from pole P to R is the measure of an angle from the polar axis OP. So what we have now is we have a pole and we have a polar axis with its initial point at 0. So whenever we try to write an ordered pair, and that ordered pair is now r and theta. So it has a radius and an angle that's made with the polar axis. So here is our polar axis right here. And here is our pole. And our point is made up of the angle theta. And it's counterclockwise most of the time if it's positive. And again, just like before when we were doing our trig, if it's a negative angle, you go clockwise. And r is the length if we fix P someplace on this ray. If that's our P, r is this distance right here. That's r. Okay, so as I noticed, r and theta can both be either positive or negative. So when r is positive, the polar distance is measured from O along the terminal side of the angle. When r is negative, it's measured in the opposite of the terminal side of theta. And again, as we know from before, when theta is positive, the polar angle is obtained by rotating OP counterclockwise from the polar axis. And when theta is negative, we go clockwise. So our r theta plane is a plane that looks like a circle. So here's what a polar graph looks like. It's usually measured off with r's that are circular, emanating out from the pole, and then usually have angle marks. Sometimes they're in degrees and sometimes they're in radians, but it's the same idea. Sometimes you'll see less lines, like this one is measured for 15 degrees, and the longer poles out there are the unit circle angles. So this is 15 degrees. Whoops. This is 15 degrees. This is 30. You notice it's out a little longer. This is 45. This is, so you add 15 to that, you get 60. You notice it's sticking out beyond the last circle, so it tells you it's one of your unit circle angles. And the next one isn't. This is 75, and this is 90. Now sometimes you don't get the 15-degree angles, and you could do the same thing for your radians. So if you're doing this in radians, this would be pi over 6, pi over 4, pi over 3, and of course pi over 2. And that continues around the circle. All right, so how do you plot these? So let's go ahead and plot these points. So point P is 5 for r and 60 degrees for theta. So we go out along the polar axis to 5 here, and then we are going to rotate 60 degrees counterclockwise. So that would take us right to there. So now we've located that point. That's point P. Point Q, we're at 5 again, and now we're going to go negative 60 degrees. So that would take us right here. So that's point Q. W, we're at negative 5 and 60 degrees. So we're going to rotate 60 degrees from negative 5, and that'll put us there. That's point W. Point V is at negative 5, negative 60 degrees. So that would be in the second quadrant there. That's V. And our next one is A. And now we're at 3. And we have 150 degrees. Since it's positive, we'll go counterclockwise. And we end up right here, 30 degrees away from the negative x-axis. So there's our A. And then finally point B, we're at negative 3, negative 150. So that puts us back over here in the opposite direction. There's B. Okay, so that's how you graph polar points. Now, what you have to be careful of in the polar plane is that there is more than one way. In fact, there's an infinite number of ways to represent the same angle. Because we're going in a circle, you always end up back where you started from. So I added a polar graph here, and we're supposed to plot the point 245 and find 3 other polar representations. So I put a different type of graph. This is another way you see it. The main angles are marked, but there's other little lines in between, and not all of them are marked. So you just have to kind of, you learn after a while exactly where you are with these. Okay, so in fact, you can tell pretty easily by counting the lines too. So if you go 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 marks. So if you want to take 90 degrees, do that over here, 90 degrees and divide it by 8, you can see how many degrees apart you are. So you're 11.5. Okay, I think 25 actually, 11.25. So you can kind of eyeball it, but all right. So let's try this. So 245. So 245. So I go out to 2. I go up to 45. That's going to be right there. That's my point P. So now I've got to come up with 3 other points for it. So one of them I'm going to do, let me just, what if I make R negative? Okay, how do I go from here? How many degrees do I have to travel to go back to this point? So how many degrees is that? So that is going to be, there's 2 choices. You could go that way or you could go that way. So I'm going to pick one of these and see if you guys can figure out the other one. So I'm going to pick 225 degrees. So I'm going to go in the counterclockwise direction to get the P. So see if you guys can come up with the angle to go in the clockwise direction. Another way I could have gone is I could have started at 2 and gone the whole way around the circle and ended back at P. So I'm going to start here and I'm going to go the whole way around and end up there. So that's going to give me an angle of 405 degrees, which is 360 plus 45. So there's another way I could get the P. And you could have also done that and gone backwards too. You could have gone the other way. Could have started here and gone the other way, around and around again if you wanted to. All right, and then finally my last way is going to be at a positive 2, but I'm going to go in the negative direction to get back around there. So that is going to be negative 315 degrees. Whoops, I guess that should go on the inside. See if you guys can come up with a couple different angles. So the other angle, I changed this to Q so I could use the same grid and I made a 3, so it's a little further away from the pole. So at 3, I'm at pi. So 1, 2, 3. So I'm here. Let me use a different color. Use blue. Right, 1, 2, 3. So that's my Q. So what are some other ways I could have got there? So now what I have is I have -3. So I am here at -3. And I don't have to go any degrees at all because I'm there, or radians. And then another one would be, what if I start at 3 and I go the whole way around, and then pi more. So if I start at 3 here, and I go the whole way around to here, I still have to go pi more. So 3 comma 3 pi. And then my last one is to start at -3. Actually, let me start at +3 and go negative pi around. So that would be here, and I would be going back that way. So again, see if you guys can come up with some different ways to get there. But that's how you graph polar points. All right. So now I want to look at polar equations. So a polar graph is a graph, the set of all points r theta that satisfy a given polar equation. So we are going to do more of polar graphs in section 6.5, but this is just introducing the basics of it. So the most basic polar equations are r equals c, which is a circle, and theta, which is a line through the origin that forms an angle theta with the pole. All right, so how do we sketch these? So sketching r equals a constant. Now, we don't have an angle in there, so that means that theta could be any angle. And since we're talking about a circular grid, we are going to have, let me just draw a quick little grid here. We're going to have a circle with a radius of 3. So it'll look like this. Because it could have any angle. Sketch r equals -2. It's going to be the same thing. It doesn't matter. I'm just not going to take the time to use the ruler. It's not going to matter that r is negative, because all that means is we'll start the circle here and we'll go around this way. It's still a circle. Sketch theta equals 30 degrees. That's just going to be a ray that's going to continue. It doesn't have any length to it, so we're just sketching a ray with an arrow on the end that has an angle of 30 degrees. So it could be any point along that line. And same if it's negative. So we're just going to sketch the negative angle. So we have a ray going that way, -45 degrees. It's supposed to be an arrow. Okay, so if you superimpose a rectangular system over the polar system, you guys need to memorize these conversions. So the first one is the equation for a circle. So you want to make sure you understand how to go back and forth between x, y, and r theta. These are our conversions. So where it starts, as I said, is you take the equation of the circle, and if you solve it for r, you get r equals the square root of x squared plus y squared. Now this is what we're doing in parametric mode. So you can figure out going back and forth. If you want to find x, you use r theta, and y would be r sine theta, because if we add x squared plus y squared, we're going to get r squared cosine squared theta plus r squared sine squared theta, which is, of course, our Pythagorean identity. So you just get our original equation. So that's where our conversion comes from. So that's why we use those. And to get theta, we usually use the idea, if you look at the graph here, that you have this angle theta here. And if we make a right triangle, what we have is that this is our y, this is our x, and so the tangent of theta will be y over x, or r, because this will translate into our r, because this is our r as well. And I'm sorry, y over x. I was looking at this one by accident. So this is y over x. So normally we say that theta is the inverse tangent of y over x. So I'm going to stop there. And as I said, you guys need to know these conversions to go back and forth. So if you're starting with one or the other, how do you get from, Cartesian to polar and polar to Cartesian? So we'll practice that in the second video.